Hello everyone. Welcome to a new playlist on superposition theorem in the network theorems of DC circuits. How we going to do this superposition theorem is not by the theory, learning the theorem statement, etc. I'll just solve a series of problems and then I will apply superposition theorem, and then you will understand how this theorem is working and how we can solve the problem. So here you can see there is a one question, and actually I have prepared this is the second question and this is the third question. Like this I have created about 7 questions. Okay, so one by one we are going to solve these questions, and then we are going to learn the superposition theorem by the way of solving these questions. So now I go back to the first question, and if you already have an idea, you can pause the video, you can try the answering this question by yourself, and then you can later compare your answer with my answer. So meanwhile I am right now solving this, so let's see how it goes. And actually I have got these questions from different sources, and I slightly modified the questions, so I myself don't know the actual answer, and this is the first time I am solving this right away in front of you. So I may make 1 or 2 mistakes in between, so please forgive me for that. But then eventually I will verify and I will correct the things in case if there is any mistake. But at the end of the day, these are not very difficult things. These are quite fairly straightforward things. So I think we'll be fine. So let's start the first question. So here we have find the current in the 1 ohm resistance. So this is the 1 ohm resistance, and we are supposed to find the current in that 1 ohm resistance. So we have 2 batteries, and both of these batteries, in fact any battery, will have certain internal resistance. So this resistor actually inside the battery, but for representation purpose it is shown like outside. Now because of this internal resistance, so as the current increases, the voltage drop in this will reduce the output voltage. But anyway, so we have these 2 batteries, and then there is a common load 1 ohm, and we are supplying the current to that battery. So now the question is what is the current in the 1 ohm resistance? Using superposition theorem we can also find. Meanwhile, I will add something to this this thing. Let's call this as the battery 1. So let's say B1 and B2. So for the total power delivered, what is the percentage of power delivered by B1 and B2? Okay, so find percentage of power delivered by B1 and B2 to the total load. Now when you say percentage of power, actually there is a certain power loss also inside this. Okay, so inside these 2 resistances, so that see what the power totally received by this 1 ohm resistance and the power supplied by these batteries will be more, because there will be some losses in this. Okay, so also let's find losses in each battery. So just as I was seeing this question, and then I got some new thought, so I upgraded the question like this. So we keep doing like that, these kind of things, because my intention is to kind of improve your understanding of the overall thing. Okay, let's do this. So what is superposition theorem? So basically we are superimposing, okay, so or overlaying. So first you take one source. So there are 2 sources in this. You take one source and you short circuit the other voltage source, and then you solve the current. Then you take another source, again short circuit the first one, and then find the current, and then the addition of these 2 currents will be the total current of the system. So that is what we will do. Okay, now consider only battery B1. So when I consider only B1, the circuit becomes like this. So here it will be a short circuit, and here it will be a 1 ohm resistance. This is 0.04 and 0.05 here, and this one is 2.05. Now as a result I will be getting a current. So the current will be in this direction. So let's call this as I1. Okay. So what is I1 I want to find out. Okay, so how do I find I1? So here you can see this is these two are in parallel, so 1 ohm in parallel. So R effective is nothing but 0.05 plus parallel combination of 1 and 0.04. Okay. So what is the effective resistance? Okay, so let us do that. So how do you calculate the parallel combination of this? So simply 1 multiplied by 0.04 divided by 1.04, the addition of these two. So 0.3846, 0.3846, 0.05. 0.3846 plus 0.05. Sorry, 0.03846 plus 0.05. 0.08846 ohms. So this is the effective resistance of this circuit. So what will be the total current? So total current I total IT is nothing but total voltage 2.05 divided by 0.08846. So which is so 23.17. amperes. Now this current will be divided among these two branches, right? So this current, whatever IT is coming, it will be divided at this point. So here I can use the current division principle and do it. So how do I do the current division principle? So I1 will be 23.174 multiplied by opposite resistance divided by sum of the resistances. Okay, so this is the current division principle. So let's do that. So multiplied by 0.04 divided by 1.04. So 0.8913 is the current. Okay, so 0.8913 amperes is the current I1. Okay, so this is the entire process for I1. Now let us consider only B2. So when you are considering the second battery, the first battery will be short circuited. So let me redraw this circuit here again. So I just draw it. So here it is short circuit and here 0.05 and here I have 2.15 volts, 0.04 and then I have a 1 ohm resistance. So here R effective is again same. I mean the circuit structure is similar. So 0.04, only the values is different. Okay. So now what is this one? So this is 1 into 0.05, that will be 0.05 divided by 1.05. So I am getting 0.047619 or 762. So to this I will add the plus 0.04, right? So that is 0.08762 is the total effective resistance. So total current will be 2.15 divided by total resistance 0.08762. So I am getting 24.53 as the 5378 as the total current. So now I got the total current. So what that current will be here, I total. So what is the current going in this branch, again in this direction? So let's call this I2. Okay, so by again current division principle, I2 can be calculated as this I total multiplied by opposite resistance by sum of the both resistances, 0.05 by 1.05. So this one multiplied by 0.05 and then divided by 1.05. Okay, so that gives me 1.1684. Okay, so 1.1684 as the total current. Now I got I1 and I2. Okay, so now if I simply add the total current, okay, so there are two sources, so one source at a time I have considered. Now I want to superimpose both the things. So I in 1 ohm resistance equal to I1 plus I2. So that is nothing but 0.8913. Okay, so that's the answer we got here, and plus 1.1684. Okay, so what is the total current? So I'm getting 2.0597, or we can simply say 2.06 amperes of current. Okay, so this is the total current in the in this resistance. So what will be the power? So power in 1 ohm resistance, power in 1 ohm is equal to I square R. Okay, so I square R, so R is 1, so it will be simply I square. So simply I will square this one, so into 2.06 into 2.06. Okay, so I'm getting 4.2436 watts. Now I want to know what is the power in all other elements. Okay, so what are the elements I am having here? Let me write down. Okay, so we have a B1, okay, 2.05 volt. Okay, so I'm just making a small table so it's easy to understand. So we have another battery, 2.15 volt. Then we have a 0.05 ohms resistance, and then we have a 0.04 ohms resistance, and then we have a 1 ohm resistance. Okay, so let me grab a pencil. Now in each case I need to know what is the current. Okay, so let's call this current and power. So I want to find the current and then power in each of these things. So already we got the current in this case, so 2.06 amperes, and then power was 4.2436 watts. Now what is the power consumed by this 0.04 ohms? Okay, so now look at the, in this case, okay, I think here I got the total current, right, in the case of B1. So the total current is 23.174. Okay, so that is in this direction, left to right. Now here the current in this branch I need to find out. Okay, so what is the current in this branch? In this case the total current minus I2 current will give me the current in this branch. Okay, so that is now I am doing for this 0.05. So 24.5378 minus 1.1684. Okay, so this will give me the current in 0.05, but which is in the reverse direction. Okay, so look at the arrow, the current will be going backward, whereas the forward current here is the total current here 23.174. Okay, so this whole thing will have a negative sign, plus 23.174. Okay, so this is again the superposition of the currents. So now let's calculate this. Okay, so what I will do, I will take, first I will take 23.174, then I will add 1.1684, because the minus into minus it will become plus. From this I will subtract 24.5378. So I'm getting minus 1.954. Okay, so minus 0.1954. Now this minus indicates that in the effective case the current will be going in the reverse direction towards the battery. That means because this in the overall circuit the current, actual current will be going towards the into the battery, because this is 2.15 and 2.05, so this is higher voltage and this is lower voltage. So this battery is actually sending power back into this. Okay, so that we have to be careful, or we have to note. Now this same current will be flowing here also, so that is minus 0.1954. So this is the current and this is the voltage, so power will be V into I. Okay, so this is the amperes. So voltage into current is power. Okay, so let's do that here. So into 2.05. So this is minus 0.4 watts. That means this battery is receiving 0.4 watts of power. Although it is a battery supposed to give the power, but it is taking power. It is basically battery is charging because the current is going into the positive terminal of the battery. That is what we have discovered here. Now what about the power loss? Okay, so I square R, when you square it, the negative sign will become positive, so the losses will always be positive. So I will be doing I square R in this case now here. So 0.1954 multiplied by 0.1954 multiplied by 0.05. Okay, so I am getting this number, so 0.02 I will round off to. Okay, so this is 0.02 watts. So what we understood is this resistance is consuming the power of 0.02, and this outside resistance is consuming the power of 4.2436 watts, and this B1 also is consuming the power of 0.4 watts. Okay, so now I want to find what is the power consumed by this 0.04 ohm resistance. So for that I need to find the current in this. So again we use the superposition principle to find the current in this. So how do we find the current in this? Now if you look at this problem, here directly I know the total current is 24.5378. This is going towards the right side. Okay, so I am taking 24.5378 as the positive current going towards the right in this case. Now here I have to find this current. Okay, so this current will be total current minus the I1 current, but this is in the reverse direction. Okay, so I'll put a minus sign, and then total current is 23.174 minus the current that is going in this I1 branch, that is 8913, so 0.8913. So this will give me the total current going in the 4 ohms 0.04 ohms resistance. So let me now calculate that. Okay, so 24.5378, okay, minus 23.174, minus I am taking inside 23.174, then it will be plus, okay, 0.8913. 0.8913. Okay, so I'm getting quite a huge current, 2.251. Okay, so let me write that, 2.2551 amperes. Okay, so now I can find the power. So I can find the power I square R. Okay, so the power is I square R, so 2.2551 into 2.2551 and multiplied by 0.04. Okay, so I'm getting 0.2034 as the power. So let me write down that power. So I can just round off to 0.203 watts. Okay, so this is the power consumed by the 0.04 ohm resistance. Okay, so next, what is the power supplied by the other battery? Okay, now power supplied by the other battery will be simply the power consumed by rest of the other components. Okay, so there are 5 components in the circuit. So the other 4 are all consuming power. Only battery B2 is supplying power. So first let's total this thing. Okay, so here it is minus 0.4 just because the current is like this, but this is the power consumed. So I'll take it as 0.4. Okay, plus power consumed here is 0.02. plus 0.203 plus major part of the power is consumed by the 1.1 ohm resistance. So that is 4.2436. Okay. So I am getting this much as the total power consumed. Total power consumed is 4.8666. Okay. So now what is the power supplied by this? Okay, so the current is same, 2.2551. So 2.2551 ampere. So now I into V will be the power. Okay, so 2.2551 multiplied by 2.15. Okay, so that will give me 4.848 watts. Okay, so this number 4.848 watts is more or less matching with this number up to the second decimal. Okay, so this can be considered. I think only less than 1% is the variation between these two, so it is considered to be accurate. So whatever this variation is because of the rounding of error. Okay. So I hope you understood this. See, the actual problem was up to here only, to calculate the power in the 1 ohm resistance. But in addition to that, we have done this, and then this is the addition, this thing. Okay. So losses in each battery. Okay. So the losses in each battery is this two, and the total output is this one. The losses are this one. So efficiency we can calculate on all that things. Okay. So this is the first problem on superposition theorem, and like this I'll be solving the more problems, in the further videos. Okay. So thanks for watching this new playlist, and if you like this video, press the like button, and you can subscribe to this channel. Thank you.